Hi students, I'm making an introductory video for you to the Pendulum Lab. So the assignment was to go ahead and open this handout, make a copy and share it with me as usual. And the handout introduces you to the time period of a simple pendulum. This is from the PHET.colorado.edu website to go with the simulation of the Pendulum Lab. We're going to investigate factors affecting time period of the simple pendulum. You'll also determine a gravitational field strength at a location by swinging a simple pendulum and performing curve-fitting linearized data. So let's go ahead and just jump to part one. Time period versus mass, length, gravity, and amplitude. So here's the pendulum. This is when you go to home, click on introduction, and you can just start swinging it. So what is the period of a pendulum? Pendulums do have wave motion. And to figure out the period of a wave, it's not just the time it takes for the object to get back to that point in a wave, it's the time it takes for it to get back to that point in the same direction. So you see when we start, right there, it's swinging from left to right. So this is the beginning, and we're approaching that beginning from this direction here, following with my cursor. So we need to know the time it takes for this object here to swing back and get to this point here from the exact same direction. If I let it go to the way it's going right now, if you pause it, it's going to come out here and come back to that point. That is not one period. That's half a period. It still needs to come back here and get to that same point from the same direction. Not a period, half a period. Right there, it has gotten back to its original point. That would be a full period. So if we're going to go ahead and put this like right there and let it go. So now we are starting right here, and it's going to go from left to right and back. So let's go ahead and time one period for this object. Looks like about 1.67. Let's give that another test. .71, so 1.67 was my first run, 1.71 was my second run. That seems pretty consistent. Now, some of the things in the handout that you are to manipulate: choose constant values for length, gravity, and amplitude. Choose the mass to be 0.1. So let's go ahead and go back to our simulation. Let's set our mass to 0.1 all the way down. And measure the time for 10 oscillations. So let's reset this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm getting 16.83. I think I started off, I counted to 11 because when I pressed play, I started counting as 1. So I actually counted to 10. I was just offset there. So we have 16.83 for 10 oscillations. So you could write that 16.83 right there. Keep length, gravity, and amplitude the same. change the mass to 0.4, and again measure 10 oscillations. So let's adjust this to 0.4. Stop it. We should keep our starting point the same. I didn't observe how much time it took. So let's get ready. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was around 17 seconds. Let's go ahead and reset it to 30. But we're going to want to turn that mass all the way down. Reset this. Go to 30. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm still getting 17 seconds. So that tells you the period of the pendulum here doesn't seem to be affected by the mass of the pendulum, because when we had it at 0.1 and when we had it at 0.4, the period, the time it took to have 10 oscillations was the same. So that tells you that period is independent of mass. It is not dependent on mass. So that's how you do part 1. It wanted you to do another 6 readings with these different mass values. So we saw no difference in 0.1 and 0.4. It wanted you to spend about, let's see, probably takes you about 4 seconds to do each period. No, it was 1.7 seconds to do each period, I think. But with that said, it doesn't take you long to do another 40 oscillations with the program for these readings right here, these masses. So let's move on to part 2. Time period versus amplitude. Choose constant values for length, gravity, and mass. Then set the amplitude to be 5 degrees and measure the time for 10 oscillations. So setting the amplitude to 5 means to take it out to right there. That's 5. And it asked you to measure the time for 10 oscillations, keeping gravity the same, change the amplitude to 10 degrees, and again measure the period for 10 oscillations, the time for 10 oscillations. So if we were to do that right now, 1, we have to start the timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're at 16.81. I counted to 11 because when I pressed play, I started counting at 1. So 10 oscillations with this amplitude took 16.8 seconds. Let's go ahead and do what the program says. Set it to 10. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 16.86 again. So what does that tell us about amplitude and its effect on the period of a pendulum? The time it takes for it to go back and forth, getting to the same point, to the same direction. I'll leave that up for you to make your own conclusion statement about that. And again, it wants you to do these other amplitudes, 15, 20, 25, and 30, just to confirm your findings. Let's go to part 3. And in part 3, you're going to investigate the choose constant values for amplitude, length, mass, choose moon from the gravity drop-down menu. So how does gravity affect this? So we're going to want to go to moon here in this drop-down menu, put that on here, and you're going to do the same kind of test. And you'll notice that all of a sudden it is slowing down. Let's reset this and do what the handout asks us to do. Choose constant values for amplitude, length, and mass. Then measure the time for 10 oscillations. Then we're going to change the gravity location back to Earth and measure those 10 oscillations again. So you could even have used your last data set that you had just completed from part 2 to do part 3, or at least half of part 3. Let's go ahead and keeping everything here the same, the length, the mass. We switch to gravity. Let's just start timing and recording now. So now we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 oscillations with the gravity from the moon would give us a time of 41.28 seconds. Now, you can compare that to the Earth gravity, which you had just measured. We had all of these same numbers except Earth's gravity, and it took 10 oscillations took us 16.8 seconds. Let's go back to the handout and the last part. What I really wanted to, you should be able to follow part 4, numbers 7 and 8 from the video at this point. What I did want to spend a moment going over with you is the graphing. So how do you do the graphing? Well, first you're going to need to go File, New, Spreadsheet, and you're going to get a new spreadsheet like this. And you can call it my Pendulum Lab Data. The things it's going to want you to plot are period, which is going to be time, versus mass. So typically we say y versus x, and it wants time versus mass. So your time is going to be your y. So we're going to want that here. Time and mass. Go back to your Pendulum Lab. I didn't record the data in this introduction for you. Let's really quick collect some data from part 1. Choose constant values. Choose the mass of a pendulum to be 0.1 for 10 oscillations. 0.1. Let's set the amplitude to, I think it'll be pretty quick if we just go to 5. We do need Earth's gravity, so let's set it to Earth's gravity. Reset and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 16.76. So let's write that data down. 16.76. And our mass was 0.1. Let's up our mass to 0.4 like it told us. You can type it in this little box right here, I believe. Nope, you can't. So now we're at 0.4. Let's start timing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 16.73. So 0.4, 16.73. So now I'm going to show you how to plot this. Highlight these columns. Go to Insert, Chart. It's going to take a second to make your chart. I usually do like to make my chart a little bit smaller because we're going to have multiple of them. Notice it says time versus mass, like I told you, y versus x. And here, time is on our y-axis, mass is on our x-axis. It's a good thing to do to write mass in what? What are the units that this is using? Kilograms. So go back to this and put kilograms like this, kg. And it should adjust it when you click off of it. That's actually puzzling. It shows mass in kilograms. And time in seconds. So you can see here that you have a flat line. And what this is telling you is that your time is not changing depending on the mass. Time is staying the same depending on the mass. So if you were to write a conclusion statement from that, that's what it would say. The time it takes for a pendulum to undergo its period is independent of the mass, meaning it does not change. The handout's instructions for the graphing tells you all graphs must have a title and axis labeled with quantities plotted in units. So at this point, I've shown you how to do that. How are you going to do another one? So let's copy all that, put it here. This is a graph of part 1, graph of part 2. It's not asking for mass versus time. It's asking for period versus amplitude. So let's write time and amplitude. And your amplitude is in degrees. And your time is in seconds. We should have had seconds here also. So again, we're going to go ahead and pretend that these are the same data. This is incorrect data here. Incorrect data. You actually need to go back and test that. But again, highlight this, insert, chart. If we wanted to change the type to a scatter plot, you can do the chart type drop down right here. And this one would work, a scatter chart. And we only have 2 points here because, again, we only have 2 XY points here. Make your graph a little bit smaller, and you can copy this, Control C, copies, and you can paste it right into here. Press Enter and paste unlink or linked to spreadsheet. It would be good to link it to the spreadsheet. So if you do it like that, now it's pasted in there, and you can still, if you want to make it smaller, click it and drag the corner to make it smaller. So that should help you a good bit. If you have questions, email me, and I'm happy to help you. Hope this helped.